Okay, question 8. So we are asked to, first we're going to get an equation of the line passing through these 2 points. So if you're looking at a part of the textbook that you can go back and revise this from, this is, or there is a similar question to this on page 67 of Jack Plus, which is worked example 21 from chapter 2. Okay, so let's get started. So the first thing we're going to do is we're going to state our vectors. So I've got O to A and O to B. Okay, now from the origin to A, it's 2, 4, and 5. And from O to B, it's going to be 3, -2, and 1. So when we're trying to get a vector equation, we are going to be using our formula of R is equal to A plus KD. Now here, A is one of the positions on the line. K is a scalar. And D is the vector traveling in the same direction parallel to the line. I'm just going to use that for parallel. Okay, and then that R will give us the position vector of any point on the line. So next thing that we're going to do is we're first going to go back to what we know about vectors. So up here, that's where I've got A, and over here is where I've got B. If I want to find the vector that joins these two things, if I want the vector from A to B, that means that I need this one to be traveling in the opposite direction, because that way I'll get this to this, which will give me that as my vector. Okay, so next thing I need to do is use my vector algebra to work this out. So the vector from A to B is equal to the vector, the reverse direction of B to O, plus the vector O to A. So all I'm going to do is chuck that in, put a minus at the front, 3, -2, 1, plus 2, 4, and 5. That gives me -3 plus 2 will give me -1i. Negative and negative will make that positive, so that'll be plus 6j and 1 and 5, or -1 and 5, so that'll be plus 4k. Okay, so now I've got, this makes up D. This is a vector that's parallel to it. So all I'm going to do is I'm going to chuck in, we'll start with A. So I'm just going to do a bit of chug and plug to figure out which one works for this. So our vector equation R is going to be equal to 2i plus 4j plus 5k. This so far matches that one, looking good. Plus k, bracket, -1i, plus 6j plus 4k. So that doesn't match that, not the biscuit. Although it could be one of the other forms. So maybe don't cross it yet. Let's take that back. Okay, so that one currently doesn't match anything. Let's try converting it into Cartesian form and we'll see what happens. So to convert it into Cartesian form, I'm just equating the x component here, or the xy component here, and the one that's here. And because it's got that scalar in front, it gets to take k. So 2 plus -1k. And if I rearrange this, that gets it into Cartesian form. So it'll be k is equal to something in terms of x. So x minus the 2, once I take it across, divided by -1. And then I'll have y is equal to 4 plus 6k. So then y minus 4 divided by 6. And for z, I've got 5 plus 4k, so then is equal to z over -5 divided by 4. Okay, so does this match any of them? No, it doesn't. Okay, so then we're going to try and use the other coordinate. So we're going to now try and substitute b in as our a in this point, because I only need to use one of the points on the line. It shouldn't matter which one. Okay, so R is equal to 3 I plus negative 2j plus 5, plus 1k, helps to look in the right spot, plus k is equal to negative 1j, plus 6, that should be an I, that's a j, plus 4k. Okay, is equal to. Now, does this match it? No, the negatives are in the wrong spot, so that doesn't match. Okay, so next thing that we're going to try is converting it into Cartesian form. So I've narrowed it down to one of these two. Okay, so x is equal to 3 minus 1k. So then x divided by, hang with me. Okay, so then y is equal to 2 plus 6k. So then y minus 2 over 6 is equal to, and then z equals 5. Is that a 5 or a 1? It's a 1. 1 plus 4k, so then z minus 1 over 4. So, haha, that matches D, so that's our answer. Okay, question 9. So I'm sure that there is an easier way to think of this, but I don't know what it is. So in an exam, this question will probably take me about 5-10 minutes. So I don't know if you would think that this is worth it in the exam, because it's going to, take some time away from the other questions, which maybe just leave this question to the end. That's what I'm getting at. Okay, so calculate the population mean is what we're trying to do. So in the question, we're given that your standard deviations of both samples are the same. Now, in this question, I'm just going to call this S for the deviation. Okay, and we are going to test these conditions. So let's just go over the formula for it again. So a confidence interval is given to you as this part here, the mean of the sample, plus minus our z-score, which relates to your confidence interval. If it's 90% confidence, then it's going to be a z-score of plus minus 1.64 or something like that. So in this question, I'm going to use that as 1.5-ish. Okay, and then if I've got a 99% confidence interval, that is like plus minus 2 point something, but it's very close to 3-ish. I don't actually know if it is very close to 3-ish. I don't remember these off the top of my head, but that's what you can do. So the next thing is it's multiplied by, now this is in specialist, so our formula that we use for this is the standard deviation divided by the square root of how many people are in the sample. So I'm just going to roll through and test. So the first thing I'm going to do is I'm just going to make a standard to test against. So, I've spelled standard wrong. Deal with it. Okay, so first, as standard, let's let z equal 2 because that's in between these two. Let's let n equal 100 because that's a square number, so when I square root it, I'll get something nice. So then that means for the confidence interval, that'll be equal to x plus or minus 2 times the standard deviation divided by the square root of 100, which will be like x plus or minus 2 over 10, which will be like x plus or minus 1 over 5s. So if I'm thinking about what this looks like, here's my mean, and my confidence interval is going to be plus or minus a fifth either way. So we are looking to try and decrease that. We want it to be closer to the mean. So now that I've got a standard, I'm going to make some comparisons. So let's do A, decreasing the sample size. Let's pick another square number. Let's pick 9. That's a nice square number. Okay, and then decreasing the confidence level. So then instead of using 2, I'm going to use, instead of 1.5, I'm going to use 1 because that number's nicer. Okay, so now let's substitute this in and see what happens. So our confidence interval is equal to plus or minus. Now, you could go to extremes with this, but remember you don't have a calculator. So while you can live your best life, try not to make your life hard. Okay, so then that's just S over 3. So that's like a third. So if a fifth is 0.2, a third is like 0.33. If I think about what this looks like, it's further out than that. So no, not A. Not the biscuit. Okay, B. Decreasing the sample size. So again, let's let n equal 9. Increasing the confidence. Let's let z equal 3. Okay, so substitute our values in. Our confidence interval is equal to x plus minus, or sorry, our mean, 3s over square root of 9, which is going to be x plus or minus 3s over 3, which will cancel out to be 1. Definitely not smaller. Okay, 1 is over here. If that's 0.3 in between here, 1 includes all the way over here and here. Okay, let's test C. Increasing the sample size, let's let n equal 1,000, and decreasing the confidence. So then let's let z equal 1. Okay, so CI is equal to x plus or minus. I'm not going to do this working out again. I'm going to jump straight to the answer. So S over square root of that will be 100. So now that is way less. That's like, if that's 0.2, this is 0.01. So you are a contender. Let's double check what happens to D. Increasing the sample size, let's let it equal 1,000, and increasing the confidence. So let's let Z equal 3. Okay, so the confidence interval will be given to you again by x is plus or minus, Z is equal to 3s over 100. So this is like 0.03. So even though this one has also decreased it, this one has decreased it by the most. So C is our more correct answer. Now, another way that you could think about testing this, because I know in the exam you'd be like, what the hell? That's 2 that have worked. But think about if you take this to the extremes. If I take this number here and this number here, and I make this one huge, and I make this one huge, then that means that, like, you know, I'll end up with something like approaching sort of 1-ish. If I take it to like infinity, it's going to be approaching 1. But this one here is going to be approaching 0, because if I make this top one tiny, the number here tiny, that means that would become a fraction. So think about if I use z equals 0.1, because that's a number smaller. So then that's really like using 1 over 10. So then my calculation on the end here would become 1 over 10s divided by 1 over, let's say, 1,000, huge number. And then now, because that's gone to the bottom, that one's always going to be the smaller answer. Even though I would argue there were 2 answers here because they both decreased, but whatever. Okay, so let's get started. We've got an argument, z plus I minus 1 plus pi on 4 equals 0. So whenever I see the z, I know that that's equal to x plus yi, or sometimes you call it a plus bi. But because we're going to be making it something that we can graph, so it correlates with one of these, then I'm just going to leave it as this. So now I've got that my argument is equal to x plus yi plus I minus 1 plus pi on 4 is equal to 0. I'm going to move this to the other side. And now in here, I'm going to group my like terms of the real and the imaginary components. So this makes up my real component. And this one makes up my imaginary component. Now, the I stays there while we've got the argument, but the next thing I'm going to do is I'm going to take this argument to the other side, which will change it into tan minus pi on 4, which is equal to 1. Now, the reason why this happens is because when I take an argument, when I say arg, I really mean inverse tan negative 1 of y over x, and then that gets me my, what do you call it? That gets me my angle. when I'm trying to get it into the polar form and stuff. So over here, I take it across, I do the inverse of this, which means that I'm getting that to be that. Okay, so the next thing that I need to do is, okay, so now I've got it to this point. I can take this to the other side by changing it just into regular tan. So tan minus pi on 4 is equal to -1. And now I've got y plus 1 over x minus 1. Now I can take this to the other side, so it'll become -1, x minus 1, bracket, y plus 1. Okay, and now I'm going to expand this, minus x plus 1, and I'm going to take that 1 from here to the other side, which will change it into -1. So they'll cancel out, and I'm left with x equals minus x. So that means I'm looking for something with a negative gradient. So it could be B or it could be D. Now, to test which one it's going to be, I can substitute in a point. So if I substitute in So this tells me that the first point that we'll get is when y is equal to 1 and x is equal to -1. So the next thing that we're going to state is the final condition, and this will help you determine which one it could possibly be. So the one that we're looking at depends on this. Now, our problem is if I substitute in 1 into this coordinate, then it equals 0. So that means that x cannot be 1, which means that it's not including it. So this one here shows that it is including 1. This one here shows that it's not including 1. So that's why it's B.